Hello everyone. Today we are going to see the nodal analysis. Nodal analysis. This nodal analysis is based on KCL. Okay. And KCL says that summation of current at a node equal to 0. Summation of current at a node equal to 0. Okay. In another way, KCL says that summation of current entering towards the node is equal to summation of current leaving from the node or outgoing from the node. Okay, the one side you have to do the summation of current which is entering towards the node, another side you have to do the summation of current which is outgoing from the node. Okay, so let us say that this is a number of branches connected to this node. Okay, this is a node. These are the current flowing to these branches: I1, I2, I3, I4, I5, and this is I6. Now we have to apply KCL to this node. So the current entering towards the node is I2, I3, I5. So therefore I2 plus I3 plus I5. This is summation of current entering towards the node. Okay. And right side is summation of current leaving from the node, and that is I1, it is leaving from the node, I4 is leaving from the node, I6 is leaving from I1, I4 and I6. Okay, so this is a KCL. Okay, and how will you find out the current? Current says that according to Ohm's law, it is potential difference upon resistance. Okay, this is a basic formula to find out the current of a branch. So current is equal to I is equal to potential difference upon resistance. Okay. So let us start. This is a one branch. Okay. V1, V2 are the two potential. We have to find out this current I. So what is I? So I, we say that is V1 minus V2 upon R. Current always flow from higher potential to lower potential. So V1 must be greater than V2. Okay. इसलिए potential difference is what it is, V1 minus V2 upon R. Okay, let us say that this is a branch V1 5 volt, V2 R. You have to find out this current I. So this current I is equal to what it is, V1. Okay, and now we are moving from positive to negative over this voltage source. So it is we call as a fall in potential. And this fall in potential or potential drop we called as a negative. We'll consider it as a negative, isn't it? So when you are moving from positive to negative over the voltage source, it will be considered as negative. When you are moving from negative to positive terminals of the voltage source, okay, we consider it as positive. So V1 minus 5 minus V2 upon R. If you want to find out the current in this direction, then this I1 is equal to what it is. So now this is higher than this one. So V2. Now this is, we are moving from negative to positive. So it is plus 5 minus V1 upon R. Okay. And both the currents are equal but are in opposite directions. So you have to assign minus sign to them. Like this. Isn't it? Okay. तो यही हम लोगों को KCL में use करना है. Now let us say that we'll see the one problem. Okay. Based on the nodal analysis. So find voltage across 5 ohm. You have to find out the voltage across 5 ohm. And let us say that this is a circuit. Okay, so this is the problem. You have to find out the voltage across this 5 ohm. Okay, voltage across this 5 ohm means voltage at this node. Okay, so KCL से हम लोग फाइंड आउट करना है. So what is the procedure is? KCL में पहला प्रोसीजर क्या रहेगा? Identify the number of nodes. Okay, so 3 or more than 3 branches meet at a point we call as a node. So this is one of the branch node. This is another node. These are we call as an active node, and this common line we call as a reference node or bottom node. Okay, so this is a one active node, this is another active node, but since between these two active node there is a short path, so potential at this node and potential at this node will be same. अगर यहाँ पे कोई एलिमेंट होता था तो एलिमेंट के अक्रॉस में पोटेंशियल ड्रॉप होता था, एंड जिसकी वजह से पोटेंशियल एट दिस पॉइंट एंड पोटेंशियल एट दिस पॉइंट विल बी डिफरेंट. ओके, बट इन दिस केस the potential at both the nodes will be same, and therefore both the nodes will be considered as a single node. Okay, if you pinch this two node, then it will be considered as a single node. Voltage at this node, let us say that it will be V, and we have to find out this V. V is also the voltage across 5 ohm. Okay, ये 5 ohm है, इसके across का voltage is nothing but potential at this point with respect to ground. Okay, so this is we call the active node, and ये जो node है इसको how many branches are connected? This is a one branch, second branch, third, and this is a fourth. 4 branches is connected. So what is the steps? For nodal analysis is, first of all, identify the number of active nodes. Okay, define the voltages at the active node. जैसा हम लोगों ने यहाँ पे voltage define किया V. अगर voltage दिया रहेगा तो दिया हुआ voltage रखना है, नहीं दिया रहेगा तो आपको define करना है, isn't it? Then identify the number of number of voltage sources. Okay, voltage sources है क्या between active node and ground, वो देखना है. अगर voltage source between active and ground में रहेगा तो that will directly give the value of active node voltage. ऐसा रहेगा, isn't it? Okay, so this is a second we said at the observation. Third observations क्या आप लोग का? डिपेंडेंट सोर्स जो है, डिपेंडेंट सोर्स जो वेरिएबल पे डिपेंड करता है उसको हम लोग डिपेंडेंट वेरिएबल बोलते हैं. सो दिस डिपेंडेंट वेरिएबल जो है इसका आप लोगों राइट दिस डिपेंडेंट वेरिएबल इन टर्म्स ऑफ नोड वोल्टेज. सो डिपेंडेंट वेरिएबल इज I1 and you have to write down what is I1 in terms of node voltage. So you have to write the equation of I1 in terms of node voltage. So I1 is what it is. तो I1 is ये ब्रांच का करंट है, ये ब्रांच यहां से स्टार्ट हो रहा है, इधर एंड हो रहा है. Okay, so I1 is equal to potential difference. So V minus 50 upon total resistance of the branch is 30. Okay, this is we say the current flowing through this branch. Okay, so ये हम लोग का this is we call as a one observation. Then we have to apply KCL to this node. Okay, so फिर हम लोगों ने KCL अप्लाई किया तो क्या क्या प्रोसीजर? The first thing is identify the node, identify active node. This is the first step. Okay, second one is define node voltages. Okay, observe voltage source, only voltage source. Observe only voltage source between active node and ground, your reference. Okay, this gives us node voltage. Okay, third, write dependent variable equation in terms of node voltage, because you are doing nodal analysis, node voltage. Okay, and fourth is apply KCL to active nodes, and fifth is solve simultaneous equation. Okay, so these are the steps. So if you see now in this problem, if you apply KCL to node, what is KCL to this node is? KCL to node V is, क्या रहेगा KCL नोड V को? तो ये करंट जो है 1 2 3 4 ब्रांचेस are कनेक्टेड. जो ब्रांच में करंट दिया, डायरेक्शन दिया नहीं है, वो हम लोग आउटगोइंग एज्यूम करेंगे. ओके, ये ब्रांच का भी नहीं दिया, आउटगोइंग एज्यूम करेंगे. ये ब्रांच का आउटगोइंग दिया हुआ है I1 से, ये ब्रांच का करंट एंटरिंग टुवर्ड्स नोड है. सो KCL says that summation of current entering is equal to summation of current leaving या आउटगोइंग. सो एक ही करंट एंटर हो रहा है नोड की तरफ, एंड दैट इज 2. आउटगोइंग करंट, ये ब्रांच का करंट क्या रहेगा? तो V माइनस 0 अपॉन 5, मतलब V बाय 5. ये ब्रांच का करंट इज V माइनस 30 I1 माइनस 0 अपॉन 10. V माइनस 30 I1 अपॉन 10. दिस वोल्टेज सोर्स है. ओके, पोटेंशियल डिफरेंस अपॉन रेजिस्टेंस प्लस V माइनस 50 अपॉन 30. V minus 50 upon 30. This is a KCL to this node, isn't it? ये KCL हुआ है नोड को. अभी इसको हम लोग को सॉल्व करना है, ये इक्वेशंस को. तो इक्वेशंस को सॉल्व कैसा करेंगे हम लोग? तो इक्वेशंस को सॉल्व करने के लिए विल टेक द LCM. ओके, LCM लेंगे. सो फर्स्ट ऑफ ऑल दिस इज 2 इक्वल टू V बाय 5 प्लस V माइनस 30. I1 इज व्हाट इट इज? तो I1 is V minus 50 upon 30 upon 10 plus V minus 50 upon 30. I1 का वैल्यू पुट किया, isn't it? So this 30 get cancel. 2 is equal to V by 5 plus V minus V cancel. This is plus 50 हो गया. Plus 50 upon 10 is 5 plus V minus 50 upon 30. Now LCM of this equation is 30. So we'll multiply this by 30, it will become 60. इसको 30 करने के लिए 6 को मल्टीप्लाई करेंगे. सो न्यूमरेटर को भी 6 से मल्टीप्लाई करेंगे, 6V. इसको 30 से मल्टीप्लाई करेंगे, 150. दिस इज V माइनस 50. ओके, सो ये अगर हम इधर लेके आए हम लोग, तो व्हाट वी आर गेटिंग इज 150 माइनस 50, 100 हो गया. 100 ये साइड में लेके आएंगे तो माइनस 40 हो जाएगा. माइनस 40 इज इक्वल टू 7V. सो V इज इक्वल टू माइनस 40 बाय 7 वोल्ट. ओके, दिस इज अ V जो कि हम लोग को फाइंड आउट करने के लिए बोला था, isn't it? सो V फाइंड आउट करने के लिए बोला था प्रॉब्लम का, तो V इज इक्वल टू माइनस 40 बाय 7 वोल्ट. ओके, विच इज इक्वल टू माइनस 5.7 वोल्ट, और लाइक दिस. ओके, थैंक यू.